Okay, this is our video on sections 2.7 and 3.3, and it's going to be on graphing inequalities and solving a system of inequalities. Now, if you're going to graph an inequality, you graph it just like you would graph a line, okay? The only difference is that you're going to have an inequality symbol in there, which means that you'll have to shade something in the end, okay? For part of your answer, when you put it on a coordinate plane, you're going to have to shade part of the graph, because not one specific number is going to be true. You could plug in a whole bunch of numbers to make the inequality true, a whole bunch of ordered pairs. So you're going to have to shade the part of the graph that will make it true. Now, our steps are to get it into slope and intercept form. And then the second part is to shade. Okay, so it's two steps to do this. And then when we shade, we'll talk more about this in a minute, you're going to need to pick a test point. We'll talk about what are good test points to pick. Now, before we get going much farther, we need to talk about inequality signs real quick. You've got less than and greater than, and then less than, that's these two, and then less than or equal to or greater than or equal to. Now, if they don't have the equal to on them, remember that means it's not included. And if it does have the equal to on there, you're going to include number, since it's got the equal to on there, anything that would equal whatever we're solving for. So we want to include those. And when we put those on a number line, the not included was an open circle, okay, because we didn't want to include that number. And the ones that were included was a closed circle, because we wanted to include whatever number our inequality was on the number line, wherever it started or wherever it ended. We wanted to include that number. Now, when we're working on a coordinate plane, we're going to use the same idea. But we're not going to use open and closed circles. They're going to be lines. And to show that it's not included, we use a dashed line. Okay, so if it's just strictly less than or strictly greater than, you're going to use a dashed line on your graph. If it's equal to in our graph, we use a solid line. Okay, and that's really important because when we're graphing it and we shade it, we don't want to include the numbers on the line if it's not included in our inequality sign. If it is included, we're going to use the solid line because we shade the graph all the way up to the line and included the line that we've drawn. Now here's our example. We've got x minus 2y is less than 4, and we're going to solve it just like we would a line. So I'm going to actually switch out the inequality sign at this point for an equal sign, just so that we're familiar, we've worked with this before, we should know how to solve this. Alright, so we got to get slope-intercept form. We're going to subtract x from both sides. Negative 2y equals negative x plus 4. Divide both sides by negative 2 to get y by itself. So y equals 1/2 x minus 2. There's slope-intercept form. Now I'm going to graph that line on my coordinate plane over here. Notice, I'm going to go back up here. Notice I'm going up to the original problem, and the inequality sign does not have an equal to on it, which means I'm going to have a dashed line when I graph this. Okay? Well, my intercept's negative 2, and then my slope is up 1 over 2 to the right. So let's put a couple points on there. Up 1 over 2 to the right, that's at 2, negative 1. We do it again. We're at 4, 0. Let's do one more. 6, 1. Now, we said it's going to be a dashed line. Okay, so that's what it looks like. And make sure that I can tell it's a dashed line. Now, the only extra step here is to figure out which side we're going to shade. And to do that, we pick a test point. Now, the best test point to pick is 0, 0. Okay? Because when you plug it into your problem, which is what we're going to do here in a minute, when you plug it in, things are going to cancel themselves out, because anything times 0 is 0. Now, there are some restrictions. Your test point cannot be on the line. And if it's an equal to or a greater than or equal to, that can't be on the line. So 0, 0, if 0, 0 happens to be on your line, you can't pick that. Okay? That's your requirement. But again, 0, 0 is the best one to pick. So you look on our graph here, 0, 0 is not on our line. It's on one side. So we're going to plug that into our original problem, which was x minus 2y is less than 4. So it becomes 0 minus 2 times 0 is less than 4. Everything over here, that's why 0 is a nice point to pick, cancels itself out. So 0 is less than 4, and that's a true statement. Now when we shade, we always want to shade the side that's true. Okay, I'll make a note of that. Shade the true side. Okay? Since our point makes that side true, our point's right here in the middle, the origin. Point makes it true, that means that whole side's true. So we're going to shade this side of the graph. Okay, and hopefully you can see that. We're shading that side of the graph. Now, if for some reason our point that we picked is false, then we need to shade the other side, because we always want to shade the true side. Whichever side of our lines would be true. Okay? And that's how we graph an inequality. Now we're going to go on to systems of inequalities, and it's just like graphing a system of equations. Okay? First thing you want to do is graph both inequalities. Okay, you will have two or more than two. You have to have two or more for a system of inequalities, and they should have the same variables. You graph both inequalities, and you need to make sure that you shade both inequalities. You have to pick test points for both, and something to remember is that your test point does not have to be the same for each one. Okay, you could pick two different test points. A 0, 0 again is the best test point to pick, but for some reason if it's on one of the lines and not the other, pick it for one inequality and then pick something different for the second one. Now your solution to these is the double shaded part, okay, or the overlap. The part where what's shaded will make both inequalities true, and that's what you want to look for. Okay, the numbers, the coordinates of points that will make both of our inequalities true. So here's our example. We've got y is greater than or equal to negative 3/4 x plus 1, and then y is less than or equal to negative 3/4 x minus 2. Now we're going to graph one, shade one, then we're going to go on to the second one. We're going to graph and shade it, and then we will look for the overlap. All right, so we're going to start with the first one here. Y is greater than or equal to negative 3/4 x plus 1. Well, it's already in slope-intercept form. So we go to 1. The slope is negative 3 over 4, so we're going down 3 to the right 4. 1, 2, 3, 4. Now I'm going to go up into the other direction. I'm going to go up 3 to the left 4, which is the same thing. It will give me, that point will be on the line too. I just moved the negative to the bottom. Notice that it is an equal to, which means it's going to be a solid line. So we're going to connect these. That's good. And then we're going to pick our test point down here and test 0, 0, because 0, 0 is not on our line. It's awfully close, but it's not on there. So 0 greater than or equal to negative 3/4 times 0 plus 1. 0 greater than or equal to, that's going to become 0, so it's just 1. That is false. 0 is not greater than 1. Okay? Since it's false, I don't want to shade the side with the point on it. Remember, I always want to shade the true side, so I'm shading this direction. Alright, let's graph our other one. Y is less than or equal to negative 3/4 x minus 2. Well, our intercept's minus 2. Slope down 3 to the right 4. 1, 2, 3 down. Over 4. We're going to go the other direction again. We're going to go up 3 over 4. It is a solid line because it's equal to. Let's connect that. Right, notice they're parallel lines, and you can see that from our inequalities over here. They have the same slope. Same slope of two lines means that they're going to be parallel and they don't intersect. Now our next step is to pick a test point. 0, 0 is not on our line, so we're going to pick 0, 0 again. 0 is less than or equal to 0 times negative 3/4 minus 2. And I got that backwards, but you'll get the same answer. 0 is less than or equal to 0 minus 2. 0 is less than or equal to negative 2. Now that's false. Okay, 0 is not less than or equal to negative 2. It's greater than. So for that one, we are going to shade the true side. So we're going to shade away from the point. Okay, now this is a special case here. There is no overlap. Okay, that's important to note. There's no overlap on this problem, and when there's no overlap, that means there's no points that will make both of them true, so the answer is no solution. And that's the answer to this problem. Now, if they did overlap, the part where they overlap is going to be your answer to the problem. Okay, but again, this is a special case. They do not overlap for this problem, so the answer is no solution. And those are your notes for sections 2.7 and 3.3 on graphing inequalities and systems of inequalities.